All right. Welcome, everyone, to this Linux Foundation Energy webinar, Grid Capacity Map, a Snapshot. We're lucky to have Roman Chabarik from Strikersoft and Harold Klomp from Vattenfall here to present for us today. Before they get started, I just wanted to note that if you have any questions, feel free to use the Q&A button in your Zoom interface. At the end of the presentation, we have reserved time to answer questions. So feel free to submit those anytime. And at the end, once we've completed the presentation, we will go through those questions in the order that they were received. So with that, we're going to go ahead and get started. So I will turn things over to Harold.
Yes, thank you very much for the introduction, and thank you everybody for joining. So let me see if I can share my presentation. Is this working? So wait, I need to press the share button as well. So is this working?
Yes, you're up.
Good. So yes, so Grid Capacity Map, a snapshot, Linux Foundation Energy. So thank you for joining. I will give just a brief introduction, and then I will turn it over to Roman, who will present the actual app. So and then we end with some Q&A. So just about me. So I'm an Analytics Hub Manager at Vattenfall Distribution. We are a distribution. We are a supply electricity. Connect about 80% of Swedish industry, 50% of all the electricity in Sweden flows through our power grids. And here are my contact details, so feel free to contact me if you want to contact me. So yeah, we'll just talk about the project, just a little bit in general about capacity maps, what are the challenges possibly. Then we have the presentation by Roman and some Q&A at the end. So how we define the capacity is sort of what is the capacity of the grid according to some definition minus current customers, and then this is the grid capacity or headroom, or there's many names for the same hosting capacity. And what is usually the case that there are certain locations maybe with excess production, and there it's usually easier to add more consumption, and vice versa. In Sweden, we have a lot of production in the north of the country with a lot of big rivers, and in the south we have more consumption than production. So usually it's very easy to connect, but more production in the south and more consumption in the north. That's just a generic and similar for many other grids. There's, of course, you can have annual capacity, or you can also include seasonality components. So maybe you have different patterns, usage pattern. In Sweden, we have a lot of electric heating. So of course that has a seasonal pattern. Some other you might have also cooling, so that also has maybe a summer pattern then. As I said, grid capacity, hosting capacity. I just included a few links to other people so we're not the only ones that develop these kind of tools. Maybe also right from the bat to explain that we have developed the technology. It's still, we have not deployed this in a production environment within Vattenfall, so it's not something that's available to our customers, but we have the tools. So we'll be presenting the tools and that we have been used. So it's not in a production state. So that may be good to mention from the start. Of course, one of the advantage that many see that it's be more transparent to make more informed decisions when asking for grid connections. So if there is a very congested area, maybe people select a different area to make their connection request. So some of the challenges, of course, that if you also what to include in this is should we include only existing customers, also include requests. So for example, in Sweden, we have a lot of requests. If you include them in the capacity calculations, then you might not have any capacity left. So that's a choice, of course, design choice you have to make. Also, we have subscriptions between different voltage levels, so that can be a limit. So you might not have the actual rating limitations. And then also how to include if you ongoing investments and planned investments into your capacity calculations. So these are considerations that you need to do when you present this the capacity calculations. So just a few about the capacity map project. There's a GitHub page, github.com/grid capacity map, and there's also a Linux Foundation page where you can find it, and you can find the GitHub from there. So the first one was published in 2022 in December. That only had support for Panda Power, and then we added support for PSSE in 2023. And then this year we added also a web interface with a scenario builder that Roman will demo, and also some initial support for Pausable and things we're thinking about in the future, maybe other grid solvers like Power Grid Model, which is another Linux Foundation project. So these are things that we could add in the future. And also, of course, something we're interested in why we have the seminar today is also to see where do you guys want to take this, because it's in the end it's a community opportunity here to take this to wherever you guys feel that you want to take it. So with that, I just want to end, and I will hand it over to Roman.
Yeah, thank you, Harold. I will share my slide deck and continue. So, hello everyone. My name is Roman Chubaruk, and I will present a grid capacity map, how we created it. I'm in IT industry from 2003. Fond of different aspects of IT and management, problem solving, and right now I'm a chief operating officer in a software development company, which is situated in 3 different countries. I'm also actively volunteering. So Strikersoft is a company founded in 2010. It has 80 plus employees located in 3 different sites in Ukraine, Romania, and Sweden. We are focusing on end-to-end development. We have different aspects and different types of tools and processes implemented. We also use different technologies to fulfill customers' demands. Also have support and maintenance and resource management. And this project we were involved in called in Swedish Tillväxtkarta, which actually helps to calculate the power grid. Power grid itself is a schematic. It's an electronic schema which can be calculated. And the idea behind is the following. Solution visualize the power grid on the map as a map vision of the power grid. It can represent connection request in tabular view. You can choose this connection request on the map. You can calculate headroom on the power grid. Headroom is a special word which represent the possibility of the power grid to connect additional connection requests. So this connection request can be of 2 types, production and consumption. We calculate both of them. And in the end, we just visualize the results of calculations. What is also interesting with this solution, we do the following. Connections can be combined or clustered into scenarios. So you can calculate not only single scenario connection to the power grid, but also a set of connection requests, including both types I mentioned, consumption and production. So, and the problem statement. So actually the power grid itself is a representation of a physical power grid on the landscape, as well as it has sort of a digital twin in CAD system, CAD system, and it can be calculated against these connection requests. And the solution we made is able to help customer managers to find a suitable place in the power grid where the connection request can be fulfilled. Also, it is a possibility to facilitate communication between customer and the power grid provider, as Vattenfall is, and as well as it can provide ability for data-driven analysis and streamline the connection flow. We, in our solution, done the following. This is actually what is implemented in the solution. So we created 3 synthetic grids and visualized them. We built that on a map of our Earth in Iceland, Great Britain, and small power grid in Germany. What is more, this solution works currently with 2 and work in progress with 3rd solver. First one is PSSE. It's a Siemens product which runs on a laptop, and you just feed it with some data related to this power grid via some configurational files, receive some output, and can judge on the results of the power grid, or results of the calculation, sorry. I'm a bit nervous, and as well as can be put in our solution to be visualized. Second solver is PandaPower. It's open source solver which works with SimCGMS format, and we actually implemented this solver just for the purpose of the demo, because the first PSSE needs a separate instance of the PSSE running on your laptop, and Siemens PSSE is quite expensive solution. PowerSible is 3rd one, and we have not yet implemented in our solution. As well as this solution can create scenarios. Let's move forward. Right now, I will talk briefly about 3 aspects. First, the data flow, how the solution works. We'll show you the component maps, and as well as continuous integration, continuous delivery. As Harald already mentioned, this solution was made open source. It is available for download from GitHub, so you can freely download it. There are guidances how to run it, as well as all the power grid and all which you will see is incorporated. Later on, you will see the link to this solution. It is available for public access as well. First is the data flow diagram. So what we have here, we have a grid analyst, we have map components and other things. So how it works actually. So we have connection scenarios, and we have implemented, as I said, Iceland, Great Britain, and small grid in Germany. As well as to calculate headroom, we have 3 solvers. PSSE, this is a desktop application with its limitations. Unfortunately, it's impossible to run it on a server as a service. But this was the requirement from Vattenfall. They use PSSE to calculate the headroom of our grid, and we implemented that. The second one is a cloud calculation, PandaPower, as well as PowerSible, as well as is a cloud solution which can be run as a service. And as soon as you have headroom, you visualize it on a map and return it back to the grid analyst who works with a solution to grid analyst or customer relationship manager, whatever who wants to use the solution. In terms of components, we have the following thing. Everything was implemented on Azure, Microsoft Azure, we used different kind of components inside Azure services like Azure AD, Postgres, PostGIS to calculate different kind of things on the map, as well as Redis. Yeah, and different kind of technologies were used for the front end and back end, as well as we used visualization part of our solution, OpenStreetMap and MapLibre, yeah, as well as tiles. In terms of DevOps, we use the following way to populate the application into live to production. So we used Azure DevOps, Azure repos, Azure pipeline, and so on. Yeah. So let's move to live demo. Probably it will be a bit more interesting. So it is available here, Grid Maps Trackers of Dev. It is available here as a repository, and we are moving to the live demo. I will, yeah, escape. So here is how the solution looks like. So we have scenario tabular view. We have, sorry, these are connections. When you mark several connections connected to the same bus, you can create a scenario. And some of scenarios are already calculated, but we will go one by one. As well as we have different views of the power grid and the interface. Here you can choose what power grid you want to focus on right now. As I mentioned, we have 3 of them. One is synthetic grid on Iceland landscape. Another one is the small power grid, low voltage power grid Oberrhein in Germany. And one is synthetic power grid on the map of Great Britain. Hexagons represent the number of, well, the the number of connection requests in a particular hexagon. And let's do the following. So we have dots, we have lines. Dots are called buses, lines are called lines. So buses represents the connection possibility. So here we can connect a couple of connections, for example. And let's move to this one. It is green. It is pre-calculated. As you may see, we have initial scenario as already calculated. And we can see some properties of this particular bus. We have some available headroom for production to be added and some available headroom for consumption available. And we will do the following. We are copying the name of this bus. We are going to connections. We search corresponding bus, and knowing that there is a possibility to connect up to 200 megawatts of production and up to 200 megawatts of consumption, we will add a couple of connection requests and we'll calculate, is it possible to connect particular connection requests? You need to understand that power grid as a schema, as a graph, and as soon as you add some capacity or consumption or production somewhere, it can make an influence on other nodes, on other buses. And this 200 megawatts is like indicative how many you can try to connect. And calculation will show you if it is still possible to connect it. Let's move. So we will choose this one. It's like 66 megawatts, right? It shows like some room still available. Let's move to also small one, this one, right? It's production, right? Let's find not big one. Yeah, we can connect this one as well, and some small production here, right? Okay. While creating scenario, we need to name it. Lean test something 5. Create scenario. Yeah. Scenario created. It's grayed out because it's not yet calculated. We need to, yeah, sorry. Yeah, this is on a second page. We have pages here. So this one is grayed out because it's not yet calculated. And while calculation, we can do both. We can calculate all network. It will take a lot of time. And you can calculate the power grid only for this particular bus. We do the second one. So it takes some time to calculate, and we will be able to switch between initial scenario calculated with current load and a scenario with 4 additional connection requests, including 2 production and 2 consumption connection requests. While doing that, you can check what in particular scenario is already calculated, but you still can check what connection request was in this particular scenario. And here we see so available production is right now 0, but this bus is still green and still consumption available 140. This is what I told you. We added only not big amount of production, but it made a huge influence on the power grid. We have no any kind of errors here, but production is right now 0. This is the first example. Let's move to another bus somewhere here. Green, red one, but still some consumption available. Let's search for it here. We'll reset. Okay. Search, and we'll collect some small amount because here we have. Yeah, let's try 12. I don't know if it will work, but still, let's try. Create connection request scenario here. Test 5, for example. Create. We are moving to scenarios test 5 and calculate. And you see it's still under voltage. This red represents the problem on this particular bus. It's under voltage. Let's check consumption. Yeah, and it is under voltage. So it's not possible to add this particular connection request. And let's move to third one. Somewhere it is somewhere here. Initial scenario. Smitte. Here we have some available consumption. Yeah, I'm returning all possible buses here. Search for particular one. And 46. Let's try 40. Let's try. Let's see if it will work. Create scenario. Yeah, here it is. It's grayed out because it's have not yet been calculated. Buses. Only buses we are calculating right now, and let's see. Production, available production on this bus is 0, but let's try to squeeze here the 40 megawatt consumption connection request. Will it work? So this is the way how we believe will be helpful to work with this data, representation of power grid, as well as ability to calculate connection requests. Yeah, consumption available 9 megawatts, and without any kind of problems, you can connect here one connection request here, project number 410. So in terms of demonstration, probably that's it. I will go back to presentation and we'll say what kind of work in progress we have right now. So we are right now we have implemented authentication via Azure Active Directory, and to be more flexible, we are trying to, well, we actually connected in a QA environment, but we are working on adding here key clock. This is
You might want to switch to presentation mode, Roman.
Yeah. Sorry for that. Yeah, sorry. Yeah, so we are implementing key clock. This is LDAP proxy, which allows you to connect different kind of LDAP providers, authentication providers. Yeah, documentation, compliance requirements, it is actually done, and we are working on third solver, Power Sibyl. And ideas, this solution can be used for planning, prognosis, forecasts, and so on. And it's open source, everyone can download it, implement, and need to stress here that solution is 100% compliant with SimCGMS format, and commonly Power Grid data is stored in SimCGMS format, so you can incorporate in a solution any kind of Power Grid in SimCGMS format. Yeah, I'm finished with my part. Propose to do a Q&A session. I will stop sharing and will pass a word to organizers.
Wonderful. Thank you so much. We do have a few questions. So the first one that was received said, can one party see another connecting party's connection requests on your map? For example, can I see my competitors' plans for grid connection, and can they see mine?
Yeah, I just have a question here. Who are competitors? So are they another analysts in?
I can try.
Yes, please, Harold.
So yeah, so the view that we were demonstrating is more the power system engineer, so the internal view. So of course, when you present this to if you have an external version of this, then you won't be showing, of course, all the grid connection requests. At least in Vattenfall, we won't do that. I mean, that would be. It's of course a design choice in the end, right? If you want to show this. But generally, we don't share the connection queue with the competitor connection request between different customers. Did that answer? So that was, I think that's the answer to that question.
Perfect. The next question was, what study assumptions are used in this assessment? I'm asking about historical generation, load, grid asset, and network topology.
Yes, good question. I'm trying to understand the question. So, of course, the model is you can include any load model or any grid model that you want. So it can be, of course, you can include historical generation load, but usually most useful is to have the actual loads and actual grid. And also possibly when you talk about to also have maybe a future scenario, 2030 scenario, something like that, that then includes also then any planned and ongoing investment that you think will be completed by that time. So to model the grid, the future grid, and then also maybe include then the connections that you believe will happen between then and now, so that are in the books. I hope that answered the question from Masha.
Okay, and if not, you can always submit a follow-up and we'll get to it. So the next one is a multi-part question, so we might want to break this up. The first part, when adding production or consumption at one bus in the network, how is the impact on other nodes calculated? Does the interface carry an impedance model of the network and run a DC load flow? Will this be updated, and does it contain network reinforcements and a sense of time for network development?
Yes, it's a long question. So the way you calculate this, as Roman showed, that you can either do like on the single bus or you can do on the full grid. Something that, of course, when you, as a grid analyst, you can, like, adding more capacity in a node is usually you add more transformers in that node. So that's usually something you can do quite easily. So you can even set up some business rules where you automatically try, if you have a violation, maybe a capacity violation in a node, that you automatically try to add more transformers, and by that way to resolve any conflict that or violations that turn up. Or you can do this totally manually, that you add these add additional capacity until you have until you can fulfill that request without any violations. So all those options, I guess, are on the table.
Yeah, the rest of the question was, I see that it considers bus voltage and circuit loading. What about stability and inter-area transfer limits? How can this data be presented in a simple way here? In the UK, NGET, which I believe is National Grid, trialed something called Connect Now that attempted to give study results to customers ahead of time and set unrealistic expectations because it oversimplified the situation. And when the connection request came in, the customer got a different answer. I believe this sort of thing could be very helpful, but I'm not sure if the back end of system design, grid expansion, planning processes are ready to work in this way.
Yeah, and that's always the case. These are, of course, this is a snapshot, so it doesn't, and again, like, even though it shows maybe you have 100 megawatts here, then there might be some and it's always, it's like if I check on the if I go shopping and I maybe go on the website of IKEA, is there any bookshelves available in IKEA store? I might get one answer. Then when I get to the store, that bookshelf might have been already taken by another customer. And the same can, of course, be also with grid connections. But yes, we don't imply this is a simple thing. And you need to, of course, also educate the end user to have reasonable expectations.
Okay. Thank you for that. Next question. Can you please detail a bit more about how you perform the calculations, perhaps running an incremental power flow and checking violations, directly jumping into an optimal power flow to enforce limits?
Yes, so the calculations, yes, so what you do is when you do headroom calculations, you increase the load in a node until you have hit some violation in your calculations.
Iteratively, yes, you iteratively increase the load until the violation. Yes, and doing that one by one, all the buses. That is why it takes the time.
And then, but you also have to set some limit, because it's usually for very large connections, the power flow might give you not a violation, but it still doesn't give you a valid valid because there might be other considerations that, for example, and the Swedish national grid, like when we have this north-south transfer, there can be there's a particularities that you might need to consider, which maybe this power flow doesn't really take into account. So that's why usually we set some limit to, like, these are the maximum that we show, so it can be lower, but we limit the max. We don't just increase till infinity. So that will probably give you a wrong answer.
All right, that was the last question, but we have plenty of time, so we can give it a minute. If anyone has any additional questions, feel free to submit those.
Yes, and yeah, maybe where there's additional information available, there's information available via the Linux Foundation website, and also on the GitHub there's also explanations and guides how to set this up. Maybe Roman, you can say just briefly how you can build and deliver. You said something about continuous integration delivery, but it was not in your presentation. So.
It was a bit, as far as I remember, we done this in the following way. You can just download the image and run it. So as far as I remember,
A Docker image.
Yeah, you just download Docker image and can run it. Probably to add some additional power grid. So it will already have this particular power grids to play with. And if you will need to add some others, I'm not sure it is just straightforward process, but you can contact me to help you with this task, because of course the most interesting part of the solution to play with real data. These particular three power grids were synthetic, so one of them was going together with PSSC, one we created manually, and another one was found somewhere, or two of them somewhere in the internet. So we just used those which are available in corresponding format and tried to do a calculation on the top of it. So if you will have possibility to download and install, please do so. If you will have any kind of questions, you can address them to me. My contacts will be on this presentation later on, put on the site. You can contact me via LinkedIn, and we will help you with that.
Perfect. Well, if there are no other questions, then we can wrap up a little bit early, but I do want to flag that this session was recorded, and so we will be releasing the video as well as the slides in the coming hours. We will send an email out to everyone who registered for the event to let them know when those are live, and we will also link to the resources mentioned within that email for further information. So with that, I would like to thank our presenters as well as all of our attendees for joining us today, and wish you all a wonderful day.
Thank you for your attention and participation.
Thank you.
Thank you.